Hi, Mike. So happy to have you on the podcast today. Could you start off by just giving us a brief overview of yourself and your journey with Promus Ventures?
Sure. Thanks, Emma. Great to be here. Thanks for having me. I have been in VC, doing VC, investing out of VC funds for over 20 years now, and in an area that has become fashionable called deep tech. 10 or so years ago, it was called frontier tech, and I don't know, it's had all kinds of different names, but mostly people call it deep tech now. But they're really very difficult problems, very massive ideas, big moats, very, very technical. I think most MBA courses would say to never do something like this, right? Is this too crazy? The numbers don't work. How does venture work? So that's the stuff that I just love. That's the area I'm in. My first venture fund that I started 20 years ago, we were focused on nanotechnology and semi-startups and quantum lasers, optical comms platforms, crazy stuff like that. Promus Ventures, I started back in 2011. Same focus that we have now. We did a lot of AI, ML. Yeah, all the way back then we were doing AI. Different than today, and we'll talk through AI here further in alongside of robotics. But back in undergrad, I was a math major and I was also an English major, but the data side of things just was always a passion to me. So all these years later, we're on our sixth platform fund and have invested in more than 100 different startups in over 30 cities around the world. We have offices in Chicago, San Francisco, and Luxembourg. Most of our investments have been in the US, but we do focus on Europe, UK, and have some investments in New Zealand and Australia. But we're early stage, so which is kind of pre-seed all the way up to Series A-ish. We invest early. So these are very long bus rides, right? You better like who you're on that bus with for a long time because, for instance, earlier this year, we wrapped up a VC investment we did in 2005. 19 years. So that's a total outlier. But the point is, these are very, very long. So you better be picky and you know what you're getting into when you kind of write the first check at the early stage. But we've been just really lucky and fortunate to invest in just some great teams and founders who've done very well. We've invested in some companies such as Rocket Lab, AngelList, Whoop, Mapbox, ISI, Flyer Labs. Those are some of the companies that are unicorns now in our portfolio and hopefully a lot more along the way. So we've just been real lucky to be able to do that. So yeah, that's a little bit of the background.
Well, hopefully a little bit of skill as well as luck. And we did have Peter Beck on the podcast from Rocket Lab, so know a little bit about the successes there. But other than the name change, how have you seen deep tech, frontier tech evolve since you've started in the space?
Yeah, the companies are all the same companies. They're all chasing after fascinating things, whether that's robotics or in healthcare or manufacturing or logistics or something, right? So, but clearly what technology has done in the back, the speed of the technology and the speed of change and the speed of compute and cloud and all these different miniaturization of things in space, if that's an area, there's different components of sort of technology change that helps these deep tech startups get to where they're going. I mean, we're going to talking a little bit about robotics today, and robotics, we'll get into all that, but the reason why everyone's talking about AI in robotics now is just what has enabled AI to come with robotics, meaning like, okay, instead of having robotics do certain tasks, they now can learn. We can talk about that later, but I think you've seen the ability now as well for a lot of different sectors and layers of a stack, say, if you want to say in space. And a decade ago, we are having to manufacture all the different elements of, say, a small sat. And now there are companies out there that will actually manufacture the sensor for you. Back then, we can't find anybody to properly make this small antenna that we want. So we're having to figure out how to do it. That is terrific. I'm not going to call it the AWS-ification of deep tech or anything, but it is that idea that there's been a lot of things now as a founding team you don't have to spend money on because other layers of the stack can come around you and help you out rather than you having to go spend it.
Mm-hmm. Well, that was a good overview, I guess, of how we've seen the industry change and how pervasive and broad deep tech can really be. But as you mentioned, this episode is about robotics. And I would love to dive a little bit more into that. And a lot of our listeners might not be exactly familiar with what the robotics industry looks like, the robotics market's like. Your words, how would you go about defining it?
Yeah. So we've been investing in robotics for many, many years. And when one of the tricky things about VC, I mean, VC is a fascinating industry, right? It's guided by power law. So there's just a small number of investments that are going to drive the returns. And like, if you look at all of our six funds in Promus, like you'll see that power law in motion. It's just kind of crazy. So you have to have these companies that are going to operate in these massive markets and can grow ridiculously quickly and very, very high gross margins and all of that stuff. So you've got to find something that is really going to dramatically change different industries. And robotics is like one of those industries. But at the same time, you have to have a lot of growth. But if you're early and you're wrong, well, you're wrong. So you don't get any parting gifts for being early with any of this stuff. It is interesting. You can go back and look at all of our failed investments, and holy cow, do we have a lot of them? And they're usually not that the technology didn't work or the team was wrong. That can't happen. But it's really not that. It's just, for the most part, too early. And like one of our earliest robotic bets was on this last mile delivery robotic platform, which today is out there. There are some companies done very, very well. This is like 2014, 2015, right? I mean, it's terrific team. So sometimes you can get it just when you have to your earlier question of, well, how has that changed now? Well, look, they have so many different things and LiDAR and autonomy and other things that have happened that they just had to do themselves and figure out themselves. So you got to kind of hang in there as a team to get through sometimes these valleys. But anyway, all to say, so robotics really is this area where some type of robotic platform, and there are ways, like you hear so much about humanoids today, and we can talk about that, but really this idea of ARR as a model, which we've seen in enterprise, and now Microsoft and some others have grown into the greatest companies of all time. But this idea that you can actually predict SaaS type of ARR models, and you put that into a RaaS, which is sort of robotics as a service, and whatever robotic type of solution that you are giving into food or security or healthcare or recycling, or these are some of the robotic companies that I sit on boards in that we've invested in. And whatever that is, you're trying to like replicate that kind of SaaS ARR model so that the market can kind of better peg and understand how they would fund Snowflake or something like that, but bringing that back and like how those multiples look and growth and everything that goes into sort of a public thought. So that's sort of like a model. And VC, you hear all the time, like it's not about, we don't fund science projects. We have to fund models that actually look and can grow very big and then float on the public market and grow tremendously and grow into very large 10, 50, $100 billion companies. I mean, it sounds trite, but like if you can't see that, then it won't work. And while robots are incredibly cool, they got to like make money. You have to find a model and customers willing to take that in industries that, frankly, there's just so many industries we've done robotics in, and you're always going to have people just sit there and not believe that it can do what it needs to do, or the robotic arms pick what they should be picking. And every one of our robotic companies is different, and everyone has different challenges in the different markets they're in. That's what makes it so fun.
So I have a couple follow-ups to that. The first is, I was shocked that you said that the technology doesn't often fail in the companies that you've invested in. It's not a technology part, but with deep tech, we think of things with long lead times, technology that's hard to develop. So I would love to hear more about just the statements that the technology is not the issue. And then also, I'm interested in knowing, how do you know when a technology is ready for the market, when an industry is ready for disruption?
Yeah. I mean, that was clearly an overgeneralization. I mean, the technology breaks every day. But this idea of, okay, where are we trying to get to? And over a period of years and a certain amount of capital, if you can't make that work because it's just too hard of a problem, because one, the technology around it isn't working as well. From a robotics standpoint, think about Boston Dynamics, right? Which is now owned by Hyundai, and they just unveiled their latest Atlas robot. I think it was even this week. They power it now by electricity, not hydraulics. So they've been around a long time. Like these are all the videos of all the robots you see doing crazy things and you're like, oh my gosh, we're going to die. They're going to take us over. And they've come so far because there's so much now that's gone into them being able to learn on their own and do some really interesting things. So now, why are we 30 years later or however long it's been that they can now be powered by electricity and my hydraulics can be put away? Well, it's just from an evolution standpoint. So technology does take a while to get done. A lot of times when I say the technology doesn't work, maybe it's not even so much that you can't do what you say you're going to do. It's that putting that platform, those robotic pieces into a certain line somewhere, if it's a manufacturing line or if it's an industry that's very, very heavy and you've got to like put this into something and it's just very difficult to take out what is there or put in or things that break. So that's like another thing. You see this a lot in healthcare, just interesting things that you think should work, but yet like the nurses don't want it or like little things you don't think about. So the technologists, the engineers, always just are just so smart and they can do so many things. It's always something else about the industry that's hard to get into. An industry is ready for disruption when it's completely backwards and doesn't understand what it's doing. And that is our favorite time, when you get so annoyed with a solution because people are doing it in just the absolute wrong way. And there's so many industries. I'm thinking of ag right now is one of our companies doing robotics and hardware into ag and what the solution is now and how they're able to come in and do something completely different. You know, one, when just the existing solutions are so backwards that you have an ability to come in and do something 10 times quicker, 10 times better, 10 times cheaper, whatever that is. And that's when management teams kind of pause across the table and then jump over the desk to hug you because there's no way you're just doing this. You're going to save us all of this money and also speed and people and labor, all this stuff. That's what you want to see. You also know it's working when they start writing large checks and you have 6 to 7 plus figure 3 to 5 year contracts paying per year for technology that, again, from an ROI standpoint, most of the robotic RAS kind of companies look at it from a labor standpoint. So it's very easy to do ROI with what some type of robotic platform will come in and take out labor. And, oh, by the way, you don't have to buy uniforms for that robot, and they don't scream and yell, and they don't take lunch breaks, and all of these things that you can really get to a place where the savings is real. We're humans. We live in this world that we control, right? And that's always interesting when you start trying to test for some of this and all of a sudden different people on the line start working much, much better because they're like, oh, well, that robot's not going to beat me. I love this big idea that like, well, robotics are just going to take over the world. There's going to be nobody left. But there are just types of jobs that I don't think anybody wants to do. And if you're in a food factory, food preparation factory where it's 30 degrees, right, and you're putting mushrooms and carrots and other things into these just massive industry of food preparation, or if you're out in the farm doing very difficult hot labor. I mean, if you're in a recycling plant where it's smelly and you've got to pick out different things on very large lines of trash, right? I mean, robotics can solve all these things, and it's fun to watch how those can take shape and move forward.
Yeah, if I could have a robot clean my apartment every day. I mean, there's the Roombas, but a little more than that would be nice. I've never heard the term RAS, robotics as a service, but makes a lot of sense. I mean, we've got everything as a service nowadays. For the average robotics company, I'm curious, they are very tailored to an individual market. Like, this is a robotics company for healthcare and this one's for ag. Or do we find robotics companies spanning all sorts of industries?
Yeah, there's a couple. I mean, you have a lot of people who will argue that a platform sort of robotics company, meaning it can go across verticals, isn't focused enough and blah, blah, blah. And I mean, I don't think there's any right answer to all that. We have an investment in a company in Munich called Robco, which sells these modular robotic systems for industrial SMBs. This idea that like all of these manufacturers who need robotics in their plants, Robco is enabling them to do that. So that's a very horizontal type of look. They don't care which vertical takes it. They don't care what your manufacturing plant is doing. They're just selling to you in ways with products that you can never buy before. But then we have many of them that are focused on different specific industries. So there's no real area that you have to do. I think many of them are focused, though, on specific verticals so they can go very, very deep. And that gets back to my earlier comment that the TAM has to be so large that you can really build a very large business out of serving that one market. And then what you also find is we always call it the sizzle, or where other industries can you move into? So if you are serving, say, food, what else can that robotic platform that you've built specifically to pick food and help out people on the line, what other things can you do? Does that then go into restaurants and retail and food preparation in that way, which is another enormous area? So I think you want to see other different applications, other different industries that your robots can go down the road as well. And if that's not the case, can you then go vertical yourself and stay within the recycling world? Can you then start building your own recycling plants if you're helping those existing, very old, very untechnology focused recycling plants take through all this trash every day? So there's a couple ways to look at it, but at the end of the day, it has to be a very, very large industry either way.
What verticals are you seeing now that have the largest addressable market?
Sure. Well, I'll tell you where the sort of the industries where we've seen the most outsized investment in robotics, and within the US and EU specifically, which is where we sort of run around. Logistics is the number one area, including warehousing and that type of thing. You have defense and security, and medical is not too far off from the defense side. And we have investments in all of those. We have a stealth investment in logistics, which is in the warehousing, storage, and retrieval problem with just unbelievable robotic technology there. And defense and security, we have an investment in a company called Lunar Outpost, which does advanced spacecraft robotic solutions focusing on lunar rovers and space resources. So try figuring out how robotics work in space. It's different than on Earth. So that's fascinating. We also have an investment in a company called Cobalt Robotics, which is doing semi-autonomous indoor security robots. On the medical side, we're investors in this company called Diligent Robotics out of Austin. So they try to solve the labor shortage and turnover issues with their autonomous robots in hospitals. So those three generally have gotten, over the last, say, 5 years, gotten the most investment in the robotics platforms. We are very excited on manufacturing, which is an emerging area, and we have done a lot in there. I think manufacturing robotics company gets 5 times as less capital as logistics. We think that's going to dramatically change. We have a lot of focus there. We have already had a successful exit, a robotic computer vision company doing robotics and industrial manufacturing. I've talked about this recycling plants. We've backed Recycle, which is in London, which is digitizing those recycling plants. I talked about Robco, which is industrial. So we're very excited about manufacturing and where that side will grow. And I've also mentioned food. We're very excited about what food, which is from a robotic standpoint, you don't think about that in food, but we're investors in a company called Chef Robotics, which is using these AI-enabled robots to help these food companies overcome labor shortages in their factories. So they've done something they announced a couple months ago, they've already prepared more than 10 million meals for customers. So I think that's interesting. Ag and construction, I think those are tricky industries. Those kind of fall on the bottom of the robotic lists. Now, there are some great companies out there, and we continue to look at a ton in both of those areas. We've invested in some of those areas, not so much hard robotics, but other types of companies. I think from a margin standpoint are very difficult. But look, there's some great companies doing very well in there as well, just not as much as the other side. So I think those are kind of the top areas to look at where robotics go into. And I think globally, South Korea is no surprise, kind of the number one country when you look at robotic units per 10,000 employees. And you would think the US would be high, but it's number 9 or 10 or something on this IFR list. But you have Singapore in there and Japan and Germany, which has made great, great progress. I think China's number 5 or something like that too. So anyway, we look less at the geography because we just believe if it's EU or US, these are very large markets and will do well. But you can clearly take this out and help out any corporation or company wherever they are.
So what are the major headwinds facing robotics at the moment. Why aren't we seeing robotics everywhere? Why isn't my Chipotle order being fulfilled by a robot?
Maybe it will. Maybe it will.
I expect it will one day.
We will see. The cloud kitchens are an interesting sort of conversation on the back of that too. But there's a paradox called Moravec's paradox, which you probably have heard of. It was taken from this roboticist out of CMU in the 80s. And it's this idea, and I'm probably going to get this wrong, but what is hard for humans is easy for machines, and what's easy for humans is hard for machines. Think about some of this, all these classic examples of a robot playing chess. They could play chess forever, like no issue, but ask them to have a normal conversation with you or tie a bow with a ribbon, like very difficult. That's hard. Like try talking to Siri and not getting random things done. That is like one of the biggest gaps within the emerging area of robotics. And again, when we talk, we haven't backed any humanoid specific solutions and companies, but clearly that's getting so much press. And it should. I mean, to your point, it would be great to have a actual humanoid doing stuff within your house. And back to Moravec's paradox, like you also have this issue of robots, they can't multitask well. They have very little common sense. So like a two-step request of, all right, wash the dishes, then put them in the dishwasher. We looked at dishwasher in the house platforms. Like that's not as easy as a thing that you would think, or playing a game and then putting the game away and putting it back into the cupboard. That kind of idea to a humanoid robot has come a long way, but we need to do much more. I think the AI side is just where this could change just dramatically. And the stuff that's going on there is just so, I mean, it truly is changing. If there was one thing that's changing robotic world, it's AI. And I hate to be so, AI is everywhere. Like, I mean, I was at CIS earlier in the year and I'm looking at AI microwaves and I'm like, okay, we've gone way too far. AI toothbrushes? No. But like this idea of trying to now go from this idea of building a computer to say, unload a box in the back of a warehouse to now enabling a team to build a generalist robot brain and a neural network, say. So think of LLMs for robots as like large behavior models. You have these large language vision models now. Google's doing this OpenX embodiment collaboration partnership with, I don't know, some like 30, 40 research labs and all these different researchers to collect this data to build. Like simulation is now, it's out of control. I mean, unbelievable. NVIDIA and their Isaac simulating things at something like, I don't know, 1,000 times faster current time. I mean, that speed of enablement, that speed of simulation, and these multimodal LLMs that have emerged and are working. Now you have to say, look, do we build a tailored solution for a robot to do this one thing? Or do we feel like a robot will be able to learn this and actually do it in a way that it can learn? That is kind of science fiction stuff, but it's not going to dramatically change a lot of the examples I gave you. But at the same time, it will change a lot of these different areas where taking boxes out of trucks. There's some terrific companies out there that have figured out an incredible technology and how to do that. Well, if you now have very strong humanoids that can go do that and understand and learn what the different kinds of boxes are, well, then you've solved a huge issue in warehousing, huge issue that no one's figured out yet. I think, again, the speed of compute and the speed of AI has now changed the way that robotic startups have to think about their solution.
So you're thinking of a future where now a robot could, well, before, like, didn't know how to use your example, wash dishes and load a dishwasher, but now it could theoretically query an LLM on how to do that. Is that the future you're envisioning?
Absolutely. And again, the more we can collaborate in terms of just understanding, and when you think about like large language vision models and then put them into behavior and then put them into something to tap into an LLM where everybody can pool from a similar resource, then all of a sudden, again, it's the exact same thing that AI is doing for other areas. But it's just remarkable to watch how that changes. You've got like Tesla with Optimus and Agility, which Amazon has partnered with, and Figure. These are just companies that have really evolved their humanoid robots to do really interesting things. So again, like the media loves the humanoid element, and there's so much going into just non-humanoid stuff. We are going to get to a point at some point where the data and the speed of intake into the pool of vision and imagery and other things will enable robots to do things that, they've never been able to do before.
Are there any other gaps besides ones you mentioned that you think that entrepreneurs or innovators could look to fill? Enabling technologies perspective.
Oh, from enabling? Well, I think all the things I just mentioned, again, those are at the heart of what founders now can tap into. Again, these large behavior models and large language vision models, those are just massive. So when you have physical IO devices, like these robotic arms, when you merge them into these multimodal LLMs, that's really interesting stuff. And the ability to also port out operating systems. We've seen some of our robotic companies build that and do really interesting things, like how does a security robot get into an elevator and go up and down 100-story large buildings? Someone had to do that. The ability to actually port out different layers of the stack that you've built internally to help out any mobile robot, like that's incredible. So all of a sudden now you go from selling a certain stack or trying to solve a certain solution to be able to outsource different elements within an operating system, if you want to look at that for different robots. There's a lot of that. I think one of the issues that most all of our robotic teams have to deal with is just the education of the market in terms of how that works. And you always have to find someone willing to take a risk to do something. Once they do and they see it works, then they can be referable. And now you have other very large customers. And it's always, always difficult for every company to get into some industry and then convince that industry that their robotic solution is going to work. And it does work. And not only is it like better for the company and their margins, but it's better for their output and throughput. So there's a lot of go-to market stuff that sounds mundane, but is very important when you look at it from a robotic founder.
Do you think that trust in these systems is a major barrier to people adopting them?
Absolutely. And it could be a large enough variable, Emma, where there are industries that just are going to take way longer. Because you have to put yourself in the management suites of all these companies. When you have a line working, you can't stop that line. So the minute there's downtime for anything, well, that's a problem. Whatever you're going to sell me and whatever I'm going to put in there better work. If it doesn't work, I'm not doing this. I need to see 5 different customers that do this. And then the minute you see it not working, and oh, by the way, like nobody's perfect. All these companies are still trying to figure out and make their technology work to the speed at which a human can work. That's the best way to think through it. You have to be so much better than a human from it. You have to be at least a certain speed, but yet you can't break down. Like humans don't break down. They can leave and they get sick and they don't call in for work. And that's how they break down. But yeah, it's very, very analytical. Like the robots should be performing and they shouldn't break. And that trust in robots breaking and then taking down a line or taking down something that you're relying on this person is very, very important. So it's a great point. The only way you get trust in a certain industry or solution is that your robot works really, really well.
Mm-hmm. Would you say that for robots to be successful, they have to be much, much better than a human? They can't just be a little bit better than human. They have to be much better.
Correct. Yeah, the ROI, when you really, every time we talk to a startup, in our mind, it's always that ROI. And yeah, how much quicker can they do it? There are things where you just can't take out all humans in a manufacturing plant or something. It's really interesting. Most of our companies will tell our startups, like, yeah, the speed's important. I care that it doesn't break. It's when you break is where you have the really biggest issues for robotic. Like, yes, they should be. And I don't know, you think about some robot going insane about doing some task. It's really actually not so much about incredible amount of speeds. It's just the ability for a robot to do that 24/7 and not ever break. Clearly so much better than what a human can do. So you'd be surprised. I think that is one learning that we've had over the last decade is make sure it works. And the speed will come.
Yeah. I feel like it goes back also to the trust issue where people need to understand how something could go wrong in order to trust it. And we understand how humans can go wrong, but machines were not yet certain. But I'd love to change gears a little bit and just hear a lot of our listeners are MBAs and people interested in the industry, just 2 sides of the same coin. What advice would you give to someone trying to work in a robotics company or start a robotics company? And what advice would you give MBA students interested in entering the VC world?
Sure. Well, passion should always be your guide. And my goodness, I mean, if you're trying to get into jobs with robotics, there's two ways really, right? You can go to a corporation or you can go to a startup, and later stage startups and early stage startups are very different. But having gone down the MBA world before and lived that, there's just nothing in the classroom that will ever compare to being on that job and learning real world things and solving problems that there's nobody else to solve it. You better figure it out. And startups are just, it's the greatest MBA classroom you'll ever have. And I'd very much recommend people from a robotics point of view, go try to find places where you can just get your hands dirty in that. From VC side, it's such a niche industry, and I ended up in VC. I don't know how you get that's very barbelled, right? You either kind of come in at the bottom and seemingly hang around for a while, or come in from the top where you've been out building companies and startups are areas that a VC firm wants to do. And so you kind of understand the experience. You don't have to be an engineer to be a good VC in deep tech. I mean, that to me is a misnomer. You just clearly need to be able to do something interesting. And again, most of the paths into VC are from founders and people who have done startups and now don't want to go down another 10-year road of a startup, but yet want to work with a whole host of startups. So the beauty of startups is you start something and it's yours. The greatest wealth that's created is it's not from VCs, right? It's from people starting companies, and they should. Like VCs have all their eggs, and they have a bunch of different eggs in the basket, and founders have one egg. Like that's their company. So the stress is much greater, but the payoff is tremendously greater too. So I think it's the most fun area to be in, and the most exciting and terrifying all at the same time.
It's an exciting world. Fancy, more elevated gambling, more thought put into it at the very least. My final question is I'd love to hear, just especially with VCs, what other technologies they're super excited about or other things that people interested in deep tech should look at as emerging industries, emerging sectors.
Sure. What we define deep tech as, we have 6 areas that we focus on. That's space and mobility, logistics, call it the same thing. We have health, manufacturing, energy, and what we call built environment, which is just connecting different areas. Those are like industry lanes, and the technology lanes, we have kind of 3 areas we talk about, which is compute and connectivity, which are kind of IoT and mobile sat comms and that type of thing. Automation, which is what we're talking about today, robotics and AI, ML and computer vision. And then we have advanced production, which is what we call distributed manufacturing, additive manufacturing. So it's those transformational technologies colliding with those industries that we look at. And that's kind of where we sit. Nobody knows the future, my goodness. I mean, none of us are smart enough to know what's coming. And there's all these transformational technologies that continue to be built. We're now in this really AI renaissance, which is the real thing, and it's changing industry. We're sitting in this, but it's a confluence of all these different areas, which results in these different productivity gains that nobody could see coming. And that's the world ahead. Nobody can know what's coming, and those who do are just liars. So I think all those different areas that we talk about, I mean, I could go into all the really neat stuff we're doing in space, and we've been in space for a long time. Those are our areas. Look, quantum's terrific, and we keep thinking now is the time for quantum, but I've said that like for 20 years. There's a lot of areas within all of those that we're very excited about.
I'm a huge deep tech fan. Hopefully after this episode, other people are fans as well. Well, thank you so much, Mike, for coming on the podcast.
Thanks, Emma. It's great to be here. Thanks for your time.